Some of the main things that will be tested on the fundamental skills review will be things such as number sense, so placing numbers on a number line, whether they be integers, fractions, decimals, also square roots and cube roots to be able to put those on a number line, so just having a sense of number. Strategies for comparing fractions, for example, getting a common denominator and comparing which fraction is bigger than the other, and also being able to apply order of operations or bed math and being able to show your steps vertically when you're doing your calculations. So we'll start with practicing some fraction operations, so add, subtract, multiply, and divide fractions. So when we're adding and subtracting fractions, we need a common denominator. So we look at the denominator and we can see that they share a common factor of 3. This one is missing a factor of 7, so I need to multiply the bottom and the top to make sure that it balances a fraction. Once I've done that, I can show the common denominator, and once I have the common denominator, the denominator is the number of pieces, the denominator is the size of pieces. When we add them together, we have 18 pieces, and we do not change the size of the pieces, so the denominator stays the same. We never add the denominators together. When we give answers, we should give our answers in lowest terms. So this shares a common factor of 3. So this is 3 times 6 in the numerator, 3 times 7 in the denominator. These can cancel out, and we end up with the final answer of 6 over 7. So 18 over 21 and 6 over 7 are the same, but one is a reduced fraction. And again, it's to do with these common factors. Just as we introduce common factors into the top and bottom to get equivalent fractions, we use common factors to reduce fractions. When we are dividing fractions, we want to often change that divide to a times. Now, that is the exact opposite of what we're being asked to do. If we're doing the opposite, we can balance opposites with another opposite, and we're doing the right thing. So if I have an opposite times, I need to do an opposite here, and the opposite is a reciprocal. So I'm going to flip that second fraction. And what that does is, instead of the divide 8, I make it a times 8, so it's its opposite. Instead of times 3, I make it a divide 3, so I've done the opposite. Once I've done that, the fraction rule for multiplication is top times top, bottom times bottom. And again, since they share common factors, we can take out the common factor of 4. These can cancel out, and so we're left with 2 over 3. Proportional reasoning is really just equivalent fractions, and we're trying to find some unknown parts. And we want to make sure we understand the times divide nature of proportional equations. So there is a times factor that goes up and down. There's the same one that goes up and down here. There's also a times and divide factor that goes left and right. And again, it's all to do with times and divide. And we can use these factors any way we want. So whatever is the most convenient, we can use that convenient multiplier to multiply or divide to get the unknown parts. To get a multiplier, we divide. So I'm going to I notice that this divisor, 15 divided by 10, works out to be a nice multiplier of 1.5. If I did it the other way around, I'm going to end up with kind of a repeating decimal, which is not as nice. So we try to use the nice multipliers. Now, I want to go in the opposite direction though. And the directionality of proportions is very important. So I have to keep track of that direction. So if I'm timesing going down, I need to divide going in the opposite direction. 6 divided by 1.5 gives me 4. So the proportion 4 to 6 is equivalent to 10 to 15. We have this is a ratio, and a ratio really is the same thing. We have a times divide multiplier that is equivalent, that we can use that multiplier to go between ratios. So I'm going to connect these two here, and I'm going to go in that direction, and I'm going to find my multiplier by dividing 9 divided by 6, and I get 1.5. So 6 times 1.5 is equal to 9. I can use that same multiplier between the ratios, these two parts, and these two parts. Now, because I'm going in the opposite direction to find the unknown part here, I have to, instead of multiplying by that 1.5, I'm going to divide by the 1.5. And 15 divided by 1.5 gives me a value of 10. So 10 to 6 is equivalent to 15 to 9 as a ratio. Now, bear in mind that there's more than one multiplier here. We could actually do this one here, 6 divided by 10, and that's going to be the same as 9 divided by 15, and we can use those multipliers to connect those two ratios. So this is called, the red one is called the ratio, the multiplier within the ratio. So that's within the ratio, between the two parts of the ratio. The blue multiplier would represent the multiplier between ratios, and that's actually called scale factor. Finding percent calculations. Percent calculations are really just proportional equations, so we can always go back and set this up as a proportional equation. So it's a times divide comparison. I can set this up as 30% compared to 100% is equal to part to whole. The 80 in this sentence represents the whole. And the nice thing about percentages is, if I divide 30% divided by 100%, I get my decimal multiplier. And this decimal multiplier is a decimal percentage. It is also a unit rate. And if I want to use that, then I can go from bottom to top times by 0.3, and I end up with 24. Okay, so that unknown proportion is 24. So 30% out of 100 is the same as 24 out of 80. Now, you may have learned a multiplying strategy for this, and this multiplying strategy would look like this. 80 times, and I can use a decimal percentage, 0.3 equals the answer 24. And we could do it like that, and that essentially is using this multiplication statement, but more in we can use this in a line like this. Now with this strategy, we have to be clear. Are we timesing or dividing? And if we're not sure, we can always go back to our proportional equation. Here it says 70 is 30% of what number? Well, I'm not too sure if I'm going to times or divide here, so I'm going to set this proportion up. So I'm going to set it up the same way, 30% out of 100. My decimal multiplier is from bottom to top, 0.3. Now, is 70% the part or the whole? It says 70% is 30%, or 70 is 30%, so 70 represents the part, and really I'm looking for the whole. That means that instead of going from, and again remember that the direction is important, going from bottom to top by times by 0.3, I want to go from top to bottom, so I need to divide by that 0.3. And doing that, I'm going to end up with, it's going to be 70 or 700 over 3, and that works out to be 266.6 repeating. Okay, so 266.6 repeating with that, oops, so that's not correct, is it? It's going to be 700 divided by 3 is going to be 233.3 repeating. So 70 out of 233 is approximately 30%. If I want to show this using my times divide strategy, I can start with my 70, and because I'm going the opposite direction, I need to divide by the 30%, and that's going to give me my 233.3 repeating. And that would represent this calculation, would represent this calculation in my proportional equation. So that this strategy of times and divide shows up in my proportional equation. Now I prefer we use times all the time instead of divide, and we often will set this up slightly differently when we talk about ratio and rate. Because with rates, we can keep track of our units and we can better keep track of whether we're timesing or dividing by what part of the ratio.